Now that you are somewhat familiar with inverse trig functions, it's now time to do a little calculus with them. At the end of this lesson, you'll be able to find the derivative of an inverse trig function. All right, you'll notice we have lots of really nice formulas here. The first one we have is the derivative of arc sine, and you'll notice it's u prime, or we usually refer to this as du. So du over the square root of 1 minus u squared. Notice that arc cosine, it's a very similar formula, but we just include the negative, just like we do when we're taking the derivative of sine, it's a positive value. If we're taking the derivative of cosine, it's a negative value. And again, if you'd prefer to have that as du, that's fine. Okay, the next one is the derivative of arc tangent. That's just equal to u prime, or du, over 1 plus u squared. And the derivative of arc cotangent is negative u prime, or du, over 1 plus u squared. And then we have the derivative of the arc secant. That will be u prime, or du, over the absolute value of u times the square root of u squared minus 1. And then the arc cosecant formula is very similar. It's just including the negative. This does follow the same pattern that we learned from our formulas before. If the problem starts with a c, then the derivative will be negative. So that pattern still holds. All right, let's go ahead and do some problems. All right, f of x is equal to arc tan of 3x. So I know from this one that my derivative is going to be du over 1 plus u squared. I just need to identify my u. So my u is going to be 3x. It's just whatever's next to the arc tan or arc cosine or whatever. So my derivative will equal du, the derivative of 3x is 3, and then over 1 plus u squared. And notice when I simplify this, I'm going to get the derivative is equal to 3 over 1 plus, be very careful on this one, 3x squared really means 3x times 3x, so this will be 9x squared. So you do have to square both the 3 and the x, and that is my answer. All right, let's try another one. This one says arc secant of e to the 2x. Well, the first thing that I need to make sure I know is what's my arc secant formula. It's going to be du over the absolute value of u, and then times the square root of u squared minus 1. So in this case, my u is going to be e to the 2x, because that's what's right next to the arc function. And so when I'm finding the derivative of e to the 2x will be 2 e to the 2x, because remember the derivative of e to the u is e to the u du. We can't forget all of our old formulas when we're doing the new formulas. And then the absolute value of u, so we'll do e to the 2x, and then the square root, and then we've got u squared minus 1, so it's going to be e to the 2x squared minus 1. Okay, a few things on this problem that we can take care of. The first thing, I'm just going to rewrite the numerator. Now in the denominator, I need to decide, do these absolute values, are they important or not? And what I'm going to say is, we have e to the 2x. E to the 2x can never be negative. It's always a positive number. So I do not need the absolute value symbols. So I'm going to drop the absolute value symbols. And then I've got a square root. And then if I have a power to a power, we're going to be multiplying the exponents. So I will get e to the 4x minus 1. And then the last step, since I was able to drop the absolute value symbols, I can cancel the e to the 2x's. So my final derivative will be 2 over the square root of e to the 4x minus 1. So that is my derivative. All right, let's try one more. We've got f of x is equal to arc cosine of x over 3. So I know that my arc cosine formula is negative du over the square root of 1 minus u squared. And then I'm going to put the x over 3 in parentheses. That's going to be my u. If we would like to rewrite that, remember x over 3 really is just 1/3 x for ease of working when we're finding the derivative. Okay, so f prime is going to equal negative du. The derivative of 1/3 x is 1/3. And then down below I have the square root of 1 minus u, which is x over 3 squared. Okay, and notice it kind of looks messy, but we're going to try to clean it up here. I'm going to have negative 1/3 over square root of 1 minus, don't forget I have to square both parts, so this will end up being x squared over 9. And now notice this looks like a mess. It's a complex fraction, and complex fractions are big no-nos. So what we are going to do is get a common denominator, and hopefully you're getting pretty good at getting a common denominator. This denominator would be 9, and I'd have to multiply it by 9, so we're going to get 9 minus x squared over 9. Okay, and still it's complex, so I still don't like it, so we're just going to keep going here. So keep the negative 1/3. I'm going to, since I have a fraction here and it's underneath the square root, we can actually separate it into two parts. So I'm going to have 9 minus x squared over the square root of 9. And then from here, I know that the square root of 9 is equal to 3. So this will now be negative 1/3 over square root of 9 minus x squared over 3. And now notice that I just have a fraction divided by a fraction, and so I can multiply by the reciprocal. So I'm going to get negative 1/3 times the reciprocal, which will be 3 over the square root of 9 minus x squared. And then from here, I can cancel my 3's. So my final derivative will be negative 1 over the square root of 9 minus x squared. So that's the derivative of our cosine of x over 3. So hopefully now you can take the derivative of an inverse trig function.